Today we are going to learn about a special type of polygon called a parallelogram. A quadrilateral with both pairs of opposite sides being parallel is called a parallelogram. This is a picture of one, so the left side is parallel to the right side and the top side is parallel to the bottom side. Here are some properties that you're going to need to know about parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So the top and the bottom have the same length, and the left and the right also have the same length. If a quadrilateral is a parallelogram, then the opposite angles are congruent. So angle P is congruent to angle R, and angle S is congruent to angle Q. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So that means if I add any two angles that are side by side, like angle S plus angle R, it will equal 180. Angle R plus angle Q equals 180. Angle Q plus angle P equals 180. And angle P plus angle S also equals 180. If a parallelogram has one right angle, then it has four right angles. So if you know any single one of these angles is 90, then that automatically makes all the rest of them 90 degrees. Okay, let's use this information to solve a few problems together. The directions say find the value of each variable. So we're going to start here. The variables that we're trying to find are the x, which is in the angle, and the y, which is on the side length. So, do you see there's one right angle? We had the property that said if there's one right angle, all the angles are right angles on a parallelogram. So, 6x has to equal 90 degrees. And if you divide by 6 to get the x by itself, x is equal to 15. Now, the top side is congruent to the bottom side, so to solve for y, we're going to write down 8y is equal to 88. Then if we divide by 8 on both sides, y equals 11. Okay, the next problem we're going to do is this one just below it. On this problem, it's important to remember that the opposite angles in a parallelogram are congruent, okay? And the side-by-side angles in a parallelogram add up to 180. We have to find x and y. We have two angles with an x in them, so we want to establish the relationship between these two angles. Since they're side-by-side, they add up to 180. So we'll go 6x plus 12x equals 180. And then we can combine these like terms. So 6x plus 12x equals 18x. 18x equals 180. Then we divide by 18 on both sides to get the x by itself. So x is equal to 10. Now, since I know x is 10, I can fill that in. 6 times 10 is 60 degrees here, and 12 times 10 is 120 degrees here. So I know how big these angles are now. Remember, the opposite angles are congruent, so now I can say 3y is equal to 120 degrees because these two angles are the same. So divide by 3, y is equal to 40. Okay, we're going to do this next one down here. In this picture, you can see we have a parallelogram that has a diagonal drawn through it, okay? So an important thing to keep in mind is if you were to extend the sides, we've got a pair of parallel lines here. And then, of course, when they draw the diagonal, we have a transversal line. And then the alternate interior angles are congruent. So this one is 55 degrees here. A triangle adds up to 180. So I can write the equation 60 plus 55 plus 2y equals 180. So 115 plus 2y equals 180. And now we'll subtract 115 from both sides because we need to get y by itself. So 2y is equal to 65. Then divide by 2 on both sides, and y is equal to 32.5. Now, for the other triangle, we're missing x, which is right here. So, since we now know that what y is, we can figure out these opposite angles are congruent. So 2 times y, of course, would be 65 degrees. So this corner angle on the bottom left is 65 degrees. So 65 is equal to 5x. And then we can just divide both sides by 5 to isolate x. 65 divided by 5 is 13. So x is equal to 13. Okay. We are going to go to the other side and take a look at a couple more properties having to do with diagonals of parallelograms. If a quadrilateral is a parallelogram, then the diagonals bisect each other. That means AP is congruent to PC in this picture, and DP is congruent to PB. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. So this diagonal AC makes one triangle on this side of the parallelogram and another triangle on the opposite side over here. Those are congruent triangles. So one diagonal will split the parallelogram into 2 congruent triangles. Okay? So now we're going to take a look at a couple more problems to practice on this. Let's look at this one. So this diagonal is split in half. So these opposite sides are congruent. So I can write the equation 3x must equal 12. And then divide by 3 on both sides to get the x by itself. So x is equal to 4. Now 4y has to equal 8. So 4y equals 8. Divide by 4 on both sides. Y has to equal 2. Okay? Now let's take a look at this next one. 28 is equal to 4x because these are the 2 halves of the diagonal that's been split in half. So we will divide by 4, and x is equal to 7. Okay, now it also says that these 2 segments are the same. So whatever 4x is the same as over here. So this is a 28 here, this is a 28 here, and this is a 28 here. So 2y has to equal 28. Divide by 2 on both sides, y is equal to 14. And that one is done. Okay, we have a couple of problems down here near the bottom that say coordinate geometry. Find the coordinates of the intersection of the diagonals of parallelogram ABCD with the given coordinates. So we're going to take a look at these problems, but we're going to need some graph paper to do these because this is working with coordinate geometry on the coordinate plane. So I'm going to look at these points and say, what's the biggest number in any of these? Let's see, I see an 8. So I want to make sure that my graph goes big enough to fill in as far as 8. Okay? So let me make my little X and Y axis. And we're going to plot these points on the graph. So we start with 3, 6, over 3, up 1, 2, 3, 4, 5, 6. That's point A. And then B is at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So there's point B. C is at 1, 2, 3, down 1, 2. So this is point C. And D is at over 1, down 1, 2, 3, 4. So here's D. So this is a long and narrow parallelogram that we have just graphed. Okay, so we are supposed to find the coordinates of the intersection of the diagonals. So we better draw the diagonals on here. And we want to know what point do they cross at. Well, it looks to me by my graph like it's probably 3, 2. But how could I verify that? Well, since we know that the diagonals have to bisect each other, we could find the midpoint of either diagonal. So let's say we use points B and D. Let's find the midpoint. So B is at 5, 8, and D is at 1, -4. So we'll use the midpoint formula, which we learned earlier this year. And it's also on your geometry formula chart. X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. So we start by labeling our points, X1, Y1, X2, Y2. We always label them the same way. And then we'll fill in our numbers to the formula. So X1 is 5 plus X2 is 1 divided by 2. Y1 is 8 plus Y2 is -4 divided by 2. So 5 plus 1 makes 6 divided by 2. 8 plus -4 is 4 divided by 2. 6 divided by 2 equals 3. 4 divided by 2 is 2. So 3, 2, that's what we got also by looking at the graph. So we have been able to verify that using the mathematical properties that we have learned. Okay, let's go on and look at some problems about testing for parallelograms. So on this paper, it says, conditions for parallelograms. There are many ways to establish that a quadrilateral is a parallelogram. If both pairs of opposite sides are parallel, then the figure is a parallelogram. If both pairs of opposite sides are congruent, then the figure is a parallelogram. If both pairs of opposite sides are congruent, this was sides and this is angles. Both pairs of opposite angles are congruent, then the figure is a parallelogram. If the diagonals bisect each other, then the figure is a parallelogram. And if one pair of opposite sides is both congruent and parallel, then the figure is a parallelogram. So these are really the same properties we just discussed, but we're kind of working backwards now, saying we don't know if it's a parallelogram. How could we tell? You don't have to check for all of these things. If it meets any single one of these criteria, a quadrilateral meets any one of these criteria, then the figure has to be a parallelogram. So down here in these exercises, it says, find x and y so that the quadrilateral is a parallelogram. Okay, so we are going to start with number 2. And let's see. On number 2, it says, what would these values have to be to make this this quadrilateral a parallelogram? Well, the opposite angles have to be congruent. So 11x has to equal 55. And if we divide by 11 on both sides, that means x would have to equal 5. So x has to equal 5. And the two angles side by side with each other have to equal 180 when you add them. So if I want to know how big that angle with the y needs to be, I need to go 180 degrees minus 55, which gives us 125. So 125 would have to equal 5y. And then if we divide by 5 on both sides, y is equal to 25. Okay? Now, that had to do with the opposite angles being congruent, so number 3 is the same. Let's take a look at number 4. We need the opposite sides to be congruent, so we need 18 to equal 6y. So if I divide by 6 on both sides, y would have to equal 3. Now, because of the parallel lines being cut by this transversal, these alternate interior angles would have to be congruent. So 45 would have to equal 9x. And if you divide by 9 on both sides, x would have to equal 5. Let's see, let's come back to this first one because this one is just dealing with sides and not angles. Here, the top and the bottom sides need to be the same. So 2x minus 2 would equal 12. Okay, on a parallelogram, the opposite sides have to be the same. So if we want to solve for x, we'll add 2 to both sides. So 2x equals 14. And then we'll divide by 2 on both sides to isolate x. So x is 7. Likewise, the left and the right sides have to be equal. So we can say 2y equals 8. Divide by 2 on both sides. Y has to equal 4. Okay? Now, let's take a look at this one. Again, because of the parallel lines here and here being cut by the transversal that goes through here, our alternate interior angles have to be congruent. So 2x and 30 have to be the same. So 2x equals 30. And if we divide by 2 on both sides, that means x is equal to 15. Now this one up here would have to be the same as this one down here. So we need x plus y to equal 24. We now know x is 15 because we solved for that. So we'll substitute a 15 in place of the x. And now if we subtract 15 by both sides, from both sides to get the y by itself, we'll be able to solve for y. So 9 is equal to y. Okay? Now, on the back, it says parallelograms on the coordinate plane. On the coordinate plane, the distance, the slope, and the midpoint formulas can be used to test to see if a quadrilateral is a parallelogram, okay? So down here, it says graph each quadrilateral with the given vertices. Determine whether the figure is a parallelogram. Justify your answer with the method indicated. Okay, so we're going to need graph paper again to do these. We're going to plot them on the graph, and we'll do one with the slope formula and one with the distance formula, and we'll do one with the distance and the slope formulas. Oh, and one with the midpoint formula. So we have several that we need to do to approach this from different ways. So we'll start with number 1, and we are going to need to plot the points on our graph. So I'm going to look and see what the biggest number is. 5, that's not very big, so I don't need a whole lot of space for this particular graph. And we're going to plot these points. 0, 0 is A, 1, 3 is B, 1, 2, 3, 4, 5, 1, 2, 3 is C, and 1, 2, 3, 4 is D. So how can we use the slope formula to figure out if this is a parallelogram? Well, if slopes are the same, they tell us that lines are parallel. So we just need to verify that the slopes on the opposite sides are congruent. From B to C, we have a horizontal line. So the slope would equal 0. Every horizontal line has a slope equal to 0. We learned that in algebra. And now for these two slopes, you can use the slope formula, or you can use rise over run. Remember, your slope formula, which is on your formula chart, is y2 minus y1 over x2 minus x1. But you can also get the same thing by using the slope formula rise over run on the graph. So I think that might be the easier way to go here. From point D to point C, we rise 1, 2, 3, and we run 1. So the rise over the run is rise 3, run 1. And when you take 3 and divide by 1, it equals 3. Now let's look at the segment from A to B. The rise over the run here, rise is 1, 2, 3, and the run is 1. 3 divided by 1 is 3. So we have equal slopes on the other opposite sides, so this would have to be a parallelogram. Okay, let's look at number 3 with the distance formula. This is again a pretty small graph. The biggest number I see anywhere here is at 3, so we don't need a very large graph for this one. Just make sure you can go out 3. So we'll plot these points. R is at -1, 0. S is at 1, 2, 3, 0. T is at 2, -3. And U is at -3, -2. Boy, that's ugly. Oh, 3, 0. I apologize. I'm like, this is totally crazy. 1, 2, 3. All right, that's better. So is this going to be a parallelogram? Well, I don't know. It's a little bit wonky. We are supposed to use the distance formula on this one. So distance formula is finding the lengths of each side using the distance formula, which we have also learned earlier this year. The distance is the square root, pardon me, of x2 minus x1 squared plus y2 minus y1 squared. So we want to find the lengths of the sides, and if the opposite sides have the same lengths, then it is a parallelogram, and if they do not, then it's not a parallelogram. I think I'm going to do the top and the bottom segments because the top one is really easy to tell the length. I don't even really have to use the distance formula here because I can count it on the graph. 1, 2, 3, 4. This one has a length of 4. But for UT, I'm going to need to use the distance formula to determine how long that one is. So point U, we had the coordinates for, was -3, -2, and T is at 2, -3. So those are our points that we're going to put into the distance formula. So we will label them x1, y1, x2, y2, just the same as we always do. And then we're going to find the distance by using the formula. So the big long square root with, in parentheses, x2, which is 2, minus x1, which is negative 3, close parentheses, squared, plus new parentheses, y2, which is negative 3, minus y1, which is negative 2, close parentheses, squared. So now we're going to go into our calculator, press the home screen, turn it on, and we're going to work this out. So second square root, then the open parentheses, 2 minus negative 3, close parentheses, squared, plus new parentheses, negative 3 minus negative 2, close parentheses, squared. And so this distance is equal to 5.099. Is 5.099 the same thing as 4 that we got for the top? I don't think so. So since they are not the same, this one is not a parallelogram. Not a parallelogram. Okay? All right, the next one we're going to do is number 5. We're going to use both the slope and the distance formulas on number 5. Looking through these numbers, it looks like it only goes as big as 4. So I'm going to set up a coordinate plane where I just go out as far as 4. That's all that's necessary. And we're going to plot these points. Whoa! Sorry. We've got, it's hard to manage all of this together. There we go. S is at negative 2, 1, 2, 3, 4. Here's point S. T is at negative 1, negative 1. U is at 3, 1, 2, 3, negative 4, 1, 2, 3, 4. And V is at 2, 1. Okay? So they've asked us to use both the slope and the distance formulas here. So the way that we can do this is by using the property that said that if a parallelogram has opposite sides being both parallel and congruent, then we have a parallelogram. So I just need to pick two sides to work with. Say I choose the top and the bottom. I want to find their slopes, see if those are the same, and then I want to find their distances and see if those are equal. If one pair of opposite sides is both congruent and parallel, we are dealing with a parallelogram. So let's look at the rise over the run for this top segment. The rise is negative because I go down 1, 2, 3. And then I go to the right 1, 2, 3, 4. So negative 3/4 is the slope of the segment SV. Let's look from T to U now. The rise is negative 1, 2, 3, and the run is 1, 2, 3, 4. So negative 3/4 here. So yes, these are parallel. The top and the bottom are parallel. They have the same slope. Now we're going to use the distance formula to find their lengths. So for SV, S, let's see if I can get this all together. Here we go. S is at negative 2, 4, and V is at 2, 1. So x1, y1, x2, y2. The distance is equal to x2, which is 2, minus x1, which is negative 2, close parentheses, squared, plus y1, which is 1, y2, which is 1, minus y1, which is 4, close parentheses, squared. And we'll type that in to find out what the length of that line segment is. So second and the square root, parentheses, 2 minus -2, close parentheses, squared, plus 1 minus 4, close parentheses, squared. Oops, not squared twice, just kidding. Delete this mess out that I accidentally hit. There's still an extra parentheses on here. Okay, enter. That is equal to 5. And that was a nice number. Okay, so now we need to find the length of TU. So T is at -1, -1, and U is at 3, -4. So we will label these x1, y1, x2, y2, and put them in the distance formula. Starting with x2, 3 minus -1, close parentheses, squared, plus y2, -4, minus y1, -1, close parentheses, squared. All right, let's put this one in the calculator. See if I can get this all to show. Second square root, 3 minus -1, close parentheses, squared, plus new parentheses, -4, minus -1, close parentheses, squared. 5 also. Excellent. That means that the top and the bottom are congruent segments, and they're parallel segments, which means, yes, this is a parallelogram, which is a long word. Okay, so I think we had one more we were going to do, which was with the midpoint formula. So we need to plot these 4 points. Looks like the biggest number is 4 here, and we're going to try to use the midpoint formula to make sure that this is a parallelogram, or see if it is. Okay, so we've got number 6. 3, 3 is F. 1, 2 is G. -3, 1 is H. And -1, 1, 2, 3, 4 is I. Just double checking my points because I don't want to make another mistake. -1, 4. That looks good. All right. So how are we going to know if this is a parallelogram or not? Well, we're going to connect the points, and we're going to connect the diagonals. The diagonals have to meet at their midpoints. So IG, we're going to find the midpoint for. So I is at -1, 4, and G is at 1, 2. So we need to find the midpoint. The midpoint of this segment. So we do x1, y1, x2, y2. We're going to add the x's, -1 plus 1, and then divide by 2. And we're going to add the y's, 4 plus 2, and divide by 2. So 0 divided by 2, and 6 divided by 2. That's 0 and 3. So the midpoint is at 0, 3. Now we need to find the midpoint of the other diagonal from F to H. If we get the same point, then it's a parallelogram. If we get a different point, then it is not. So the midpoint of FH. F is at 3, 3, and H is at negative 3, 1. So x1, y1, x2, y2. And we need to find that midpoint using that same midpoint formula. Add the x's, 3 plus negative 3 divided by 2, and add the y's, 3 plus 1 divided by 2. So 0 divided by 2 and 4 divided by 2. So 0 divided by 2 is 0, and 4 divided by 2 is 2. So the midpoint of FH is 0, 2. These points are close, but they are not equal. So this means this one is not a parallelogram. Okay, that's all I have for you today. Have an excellent day. Bye-bye.